Hi and welcome back. Today I'm going to be discussing an option for creating a good forging hammer that doesn't involve reforging a standard hammerhead into the classic crosspeen. The hammer that you see on the left is a standard crosspeen shape, and I forged it from a common sledgehammer which is similar to the one that you see on the right hand side on the anvil. Reforging a readily available hammerhead like this is a really good way to make a crosspeen or any other kind of hammer for that matter, but it does require a fairly good size forge and a fairly heavy anvil to support the work that it needs to be done to reshape a heavy hammer like this. It's great if you can do it, but if you're just starting out and you don't have a lot of equipment, there is a much simpler way to get a good forging hammer. So today I'm going to show you how you can regrind the faces of any common sledgehammer and turn it into a good forging hammer. Here I'm working with a couple of club hammers. They weigh 3 pounds. Sometimes they're called Mason's hammers, but they're just the short, stubby handled little hammers that are available just about anywhere. I believe I got these from Harbor Freight, but any hardware store carries some form of hammer like this. The hammer on the right still has the factory ground face on it, and when you buy these hammers, both sides of the hammer are going to be identical. The face is going to be ground more or less flat, and the transition between the face and the bevel that surrounds the face is going to have a very, very sharp edge on it. If you try to forge anything with a hammer face like this, you're going to find that those sharp edges are going to dig into the work, and they're going to create scars that are going to be very, very hard to forge out. The hammer on the left shows how you should be grinding the face of any crosspeen or forging hammer. This view of the hammer shows the main striking face of the hammer, and it is going to be used to do most of the forging at the anvil. This face is divided into two separate forging areas. There's the main striking surface, which is flat, and that is directly in the center of the hammerhead, and there are two curved edges on either side of this flat section. The dimensions of these curved edges can vary quite a bit, and it's really a matter of personal choice. Some people prefer larger curved edges, and others have edges that are barely curved at all. It all depends on how you intend to use the hammer. Now I've turned the hammers around so that you're looking at the side profile of each hammer. The hammer on the right is still the factory face, and the one on the left shows the modification that I've done to create a crosspeen on that side of the hammer. So believe it or not, this tiny ridge that I've ground into this face is all that is necessary for a crosspeen. You don't have to have that classic crosspeen shape. As long as you have a raised section that is perpendicular to the handle right in the middle of the face somewhere, you're going to have an effective fuller that's going to allow you to spread the metal across the width of the bar. So with these two simple modifications, you've created an effective forging hammer. You haven't changed the overall weight of the hammer, so if you started off with a 3-pound hammer, you still basically have a 3-pound hammer. And more importantly, you haven't changed the balance of the hammer, because if your only option to create a classic crosspeen is to grind away one end of the hammer, you're going to drastically change the weight of the hammer and the balance of the hammer. It's going to feel a lot more clumsy. So this solves both of those problems, and it's a modification you can do in about half an hour with an angle grinder. The only other modification that I would highly recommend is to replace the handle that comes with these hammers. These hammers usually come with a handle that is really short, and it tends to be very round in cross section, and that makes it really hard to hang on to. And more importantly, it makes it almost impossible to control the angle of the hammerhead as you're forging on the anvil. And again, that's personal preference, but I would at the very least modify the shape of the handle so that it's more of an oval shape. so that you can tell where the hammer face is at all times. To explain why all this is important, I've decided to tack on a video that I made a few years ago, actually quite a few years ago, about all the basic forging techniques that are used in the blacksmith shop to shape metal. I do have to apologize for the video quality, but it's still a good video that really does a good job, I feel, of explaining how the hammer and the anvil have to work together to move metal. It's not just a matter of applying pressure to metal. That pressure has to be applied in a certain way to get the metal to move the way you want it. So this video does explain that very well. And hopefully these two videos together will give you a clear picture of how that whole process works. In this video, I'm going to be covering all of the basic hammering techniques that a new smith needs to learn and master. So here's where we all got started. I think this is day one for just about everybody. You take a bar, put it dead center in the anvil, and then take a hammer and start beating on it. It's the basic driving a nail home technique. It does have its uses, but unfortunately the processes that are going to give you the most trouble can't be approached in this way. So the first thing that you have to learn is that working in the center of the anvil with the flat face of the hammer is the most inefficient way of moving metal. So that technique is only used for processes where we either don't want to move any metal at all, or we're making very, very slight changes to the shape of the piece. So for example, here I'm turning a square bar into a round bar. I'm not making the round bar any smaller, I'm just turning that square bar into a round bar. So all I need to do is to drive the corners of that square bar back onto itself and create a round bar. If, for example, I wanted to flatten this bar and turn it into a rectangular shape with rounded corners, the first thing you're going to notice is that you're going to have to really step up the amount of hammering that you're going to need to do to get this done. It's okay for short runs and for making slight changes like I have here, but you wouldn't use this technique to make any drastic change to this shape. The second technique that you need to learn is called drawing down, and that involves making drastic changes to the thickness of the bar, but not necessarily to the width of the bar. And for that technique, you need to move away from the flat face and tip your hammer over slightly until it starts forging with the rounded corners of the hammer face. If you're only forging a slight taper, you can stay in the center of the anvil and just use the corners of the hammers to start forging the bar out. The rounded corner of the hammer drives into the metal much easier than the flat face can, so it pushes the metal along the same way that a rolling pin does with a piece of clay. So you use this technique to do the rough shaping, and then you go back to the center of the anvil and with the flat face start refining that surface to the finished dimensions that you need. If you need to make more of a drastic change to the shape, you can use the same hammer technique, but take the whole thing over to the edge of the anvil. Now the rounded corner of the anvil works with the rounded corner of the hammer, and the metal is being pinched from both sides. So that has a very dramatic effect on the shape of the metal, especially as it gets thinner. This is a great technique for moving a lot of metal, but it's also a dangerous one. You get hooked on seeing that metal growing out of the bar, and it's pretty easy to overshoot your target and to forge in a thin spot that you can't hammer out later. So as you can see, the basic technique that I use is to hammer a series of fullers along one edge of the bar, and then I'll flip it 90 degrees and do the same thing to the other face of the bar. The metal here is going pretty much in one direction, so there really isn't any need to tumble the piece back and forth. I just find it easier to do a run of fullers on one side and then flip it, do a run of fullers on the other side. And again, the basic technique for all forging really is to do the rough work during the hottest part of the heat, and then as the bar cools down, bring it back to the center of the anvil and use the flat face of the hammer to start refining that shape to see where you are and where the next heat has to go. The third technique that you need to master really isn't a technique in itself, but it's the ability to shift gears and to be able to go from heavy hammering and move into something that really requires very little effort. A lot of people have trouble putting a point on a bar, for example, and it's mainly because they really haven't been able to develop a sensitivity for how little pressure it really takes to move such a small piece of metal. The key to forging a point on a bar is to first establish the slopes on the four sides, and then to develop those slopes into a point. If you try to mash the two sides down to a point and then turn it over 90 degrees and mash those two sides back to a point, you're basically just going to start work hardening that piece, and it will crack. Hammering a chisel point, on the other hand, is really just a matter of putting a slope on two faces of the bar and then turning the bar 90 degrees to control the width of that chisel point. The rounded corners of the anvil can also be used to hammer in what I call offsets. And offsets are basically just areas where a bar transitions from one dimension to another. The rounded corner of the anvil is a pretty convenient way of putting a nice smooth transition into a bar. Here I'm using the flat face of the hammer because I want to push the entire piece into the corner of the anvil. So what this transition allows me to do is to continue drawing down the end of the bar into a much smaller dimension. And when I'm done, that offset will just turn into a smooth curve between the two sections. Anytime you're drawing down a long, thin taper, you always establish the point first, and then you draw the taper down to that point. Now that the point is established, I can go back and establish the main dimensions of that section. Again, notice the rough forging and then finishing up with the flat of the hammer on the flat part of the anvil. Now we're shifting back into low gear again, and we're turning a loop on the end of this bar. I start by wrapping the tip around one of the rounded corners of my anvil, and then the rest of the process is really just tapping it into shape with very, very light hammer blows. The key here is to have a very smooth taper without any irregularities, so it just naturally wants to form into a curve when you tap it around. Here I'm setting up the next part of the process, and you can see how that transition really simplifies this sharp bend. This sharp bend is going to turn into a larger loop on the end of this bar. I'm going to be able to start it the same way I did the smaller loop, but I won't be able to complete it there. I'm going to need to finish shaping this bend over the horn of an anvil. That can either be the horn of your main anvil, or as I have here, a small stake anvil. And the reason I have to do that with this one is because unlike the smaller loop where I started from the tip and started curling it towards the back, this one I'm starting at the back and working towards the tip, so I don't really have any way of shaping that loop without hammering it around some kind of a form. So here's another angle of what I was doing. The tip isn't hot because I dipped it in water before coming over here. I need to hammer on that section, so cooling it down will keep it from getting bent out of shape. So here's a technique for hammering a bar around a horn or a mandrel. To tighten the ring, hammer the unsupported end of the loop down off of the tip of the horn. To hammer the ring back open, you move the horn over to the unsupported side of the loop, and then you hammer down on the section of the ring that is attached to the handle. So now that we've covered the three main techniques of forging metal along with a few related topics, we're ready to move on to the fourth technique, which involves using the opposite end of the hammer. The cross peen is the wide, narrow face of a forging hammer, and it sits 90 degrees to the handle. And its job is to move metal across the width of the bar. So it's basically doing the same job as drawing down, only instead of making the bar longer, cross-peening makes the bar wider. The last technique that you need to learn about is called upsetting. When you're upsetting the bar, you're hammering the bar back onto itself to make it thicker. The simplest form of upsetting is when you just need a little bit of extra material at the end of the bar. So for that application, all you need to do is to take a short heat off the end of the bar and then take a very light hammer and drive the end of the bar back onto itself. I always use a light hammer when I'm upsetting. The lighter hammer seems to deliver more of a sharp impact, which seems to be beneficial for this process. I also rotate the bar as I'm hammering, so that tends to correct any tendency for the bar to veer off in one direction or another. Now, it may not look like I did a whole lot, but when I push the metal all over to one side, you can see that I've actually gained a fair amount. The other application for upsetting is to provide some extra material somewhere along the length of the bar. Here I'm setting up to demonstrate what's normally referred to as a square corner. When you bend a bar without modifying the shape in any way, the inside and the outside of that bend are curved. When you're forging a square corner, you're actually tightening up that curve to such a point where you're able to hammer the ends of each bar that's going into that corner. And once you do that, you can start upsetting those two bars to get the extra bit of material that you need to fill in that radius and provide that nice outside square corner. So that's the whole story. In terms of forging metal, there hasn't been anything made in the last 3,000 years that has used anything but the techniques that I've shown you in this video. There are a lot of variations, and there are countless numbers of combinations of techniques that you can use to build something, but it still all boils down to a series of sequences that involve these basic techniques. Hi, I'm Dennis, and thanks for watching. If you have any questions, you can contact me by using the email address that I have shown here. If you like the channel and the work that I'm doing, please consider becoming a patron. Every dollar you contribute will bring me one step closer to being able to produce videos full-time.